approximate integral 0 to 2 x cubed dx, taking 4 subintervals of equal width using trapezoidal rule. So we are dividing it into 4 subintervals of equal width, 0 to half, half to 1, 1 to 1 and a half, and 1 and a half to 2. So T4 will be f of 0 plus f of half by 2 into the width, which is half, plus f of half plus f of 1 by 2 into half, plus f of 1 plus f of 3 by 2 by 2 into half, plus f of 3 by 2 plus f of 2 by 2 into half. So this would give you 0 plus 1 by 8 by 2 into half, plus 1 by 8 plus 1 by 2 into half, plus 1 plus 27 by 8 by 2 into half, plus 27 by 8 plus 8 by 2 into half. Note that your fx is x cubed, and substituting you will get it as 17 by 4. So let's do one more problem on this. A function f passes through 2, 7, 3, 11, 6, 18, 8, 12 and 12, 9. Estimate integral 2 to 12 fx dx using left rectangular approximation or the left sum and the trapezoidal approximation. So we start with the solution. Using the left sum, this will be f of 2 into, so we have 2, 3, 6, 8 and 12. So f of 2 into 1 plus f of 3 into the width is 3 plus f of 6 into the width is 2 plus f of 8 into the width is 4. F of 2 is 7, so 7, f of 3 is 11, so 11 into 3, f of 6 is 18 into 2, and f of 8 is 12 into 4. So substituting, you can get the answer as 7, you will get the answer. Now coming to trapezoidal approximation, you can calculate the answer using your calculators, or you can just calculate it manually. So trapezoidal rule, using this, it would be f of 2 plus f of 3 by 2 into 1 plus f of 3 plus f of 6 by 2 into 3 plus f of 6 plus f of 8 by 2 into 2 plus f of 8 plus f of 12 by 2 into 4. So simplifying, you will get this as 7 plus 11 by 2 plus 11 plus 13 by 2 into 3 plus 13 plus 12 by 2 into 2 plus 12 plus 9 by 2 into 4. And you can simplify and get the answer. Now, given a graph, if the graph is in this way, this is said to be concave down. And when it is concave down, the area of the trapezoid will be less than the actual area. Because if you have a trapezoid here, it will be something like this. And if you have a graph which is like this is said to be concave up. In this case, the area of the trapezoid would be greater than the actual area, because the actual area would be something like this. So now integral a to b fx dx represents the area under the curve. So that is the very basic concept of definite integral which we have seen so far. And if the graph is concave down, we have seen the concave down graph. So if the graph is concave down, the area of the trapezoid will be less than or equal to integral a to b fx dx, and this will be less than or equal to the midpoint sum. And if the graph is concave up, in this case the midpoint sum would be less than or equal to integral a to b fx dx is less than or equal to area of the trapezoid. So we have roughly worked out problems on calculating the midpoint sum, trapezoidal rule, and seen what is a concave up and concave down graph.